Right, here's a summary of some of the exponent shortcuts and how we can use them. What I'd like to do is to sort of teach the value of the shortcuts by trying to get you to demonstrate where those shortcuts come from. So in the homework assignment, you see lots of different things that need to be simplified, and my challenge for you guys is to simplify using more than one technique. And one of the techniques that we have is no shortcuts at all, just variable expansion. So that's one of the options we have for showing more than one technique is don't use any shortcuts. All we can use is the commutative property and the fact that exponents mean multiply the base that many times. We could also use negative exponents, mean the reciprocal of the base. So that's what I'm going to do here. I'm going to expand this with no shortcuts. The first thing I can recognize is the negative 2 power means not multiply but divide by 3x. The 2 means do it twice. So I take 1 over 3x and 1 over 3x. That's really what 3x to the negative 2 stands for. So I'm going to take 5 multiplied by x times itself 4 times, and I'm going to divide by 3x and 3x, which is dividing by 2 3's and 2 x's. Here I can see you can divide out all the common x's to 1's, and we end up with 5x squared over 9. So that's one approach. I didn't use any shortcuts. All I used was the definition of exponents and the definition of negative exponents. Now, trying it with shortcuts, I can first apply the power of a product. In other words, I can just put the exponent negative 2 on both the 3 and the x. So that's what I did there. Then I'm going to rearrange and use the product rule. And using the shortcuts, I can jump right to 5 over 9 times x squared, which is the same as 5x squared over 9. So using shortcuts, you can see you can get there a lot faster, but in our mind, we should understand what's really going on. Another way to do this problem with using shortcuts, but using different shortcuts, would be to just take care of the negative exponent first, which makes this 1 over 3x squared, which gives me 5x to the 4th, and then I use power of a product here to get to 9x squared, and then 5 divided by 9, it's 5 ninths, x to the 4th over x squared. I'm going to use the quotient rule. 4 minus 2 gives us 5x squared. So 3 unique approaches to getting the same result. If you can do at least more than one method or approach for every problem, it's more likely that you understand and are not just guessing at your work. So that's why I'm challenging you to stretch your thinking and do more than one approach for each thing. Here's an example of more than one approach, and the first one is expansion. Don't use any shortcuts at all. So I just took the inner base, this whole thing, multiplied by itself 4 times. Thank you, copy, paste. Then I could use the commutative property so that shows I could multiply in any order I see fit. So I'll take all the negative 3's, I'll take all the x's and all the y's and add them together, multiply them together. And then here we have 4 sets of x squared for a total of 8 x's, 4 sets of y to the 5th for a total of 20 y's. So we can get negative 3 to the 4th, x to the 8th, y to the 20th, or 81x to the 8th, y to the 20th. Now with shortcuts, we're going to take this and show that there's really 4 sets of each number inside the parentheses. 3 to the 4th is 81, x squared to the 4th, now I'm using power of a power, is x to the 8th, and then there's 4 sets of y to the 5th for y to the 20th. So this says 4 sets of y to the 5th, this says it in a shorter way. So that's all we're doing here is learning the shorthand notations for mathematics so that we can do our work more efficiently and not have to do all this stuff in the future. One last example. This one is one problem that some students don't understand how you can do this in more than one way. That's what I want to demonstrate. The first thing I do, of course, is I do the commutative property. I rearrange the order to put the variable and non-variable expressions together. And 4 times 2 is 8. Then I do the negative exponents rule, and I expand everything. Then these things divide out, and I end up with 8 divided by x. Alternatively, we can multiply them together using the product rule. X cubed times x to the negative 3 times x to the 2 is x to the negative 3 plus 2, which is 8 times x to the negative 1. X to the negative 1 is really 1 over x, so we get 8 over x here. Same result. Finally, an exploration. I think we all know that x to the 4th divided by x to the 4th is equal to 4x's on top and 4x's on the bottom, each of which divide out, which is 1. But we just learned a rule called the quotient rule that says if you divide numbers of the same base, subtract the exponents. If I subtract the exponents, I get 0. What does that mean? Well, it means x to the 0 equals 1. We already knew it, but now you have another proof. This is why x to the 0 equals 1, because we're dividing out all the common factors and getting nothing but 1's left. So this is a row of 1's. Similarly, if I took x cubed over x to the 4th, I would see there's 3 x's on the top dividing with 3 x's on the bottom, leaving me an x on the denominator. That's 1 over x. However, I have a quotient rule that says subtract the exponents. When I do, I get x to the negative 1. What does that mean? It means x to the negative 1 is synonymous with 1 over x because the quotient rule is not wrong. So here you can see the quotient rule can prove negative exponents, and the quotient rule can prove 0 exponents, and everything's making sense and all tied together. Have a nice day.